in this afternoon. Firstly, we would like to thank AIR Summit for giving us a quick platform to share from our startup, which is Specular Service Private Limited, about additive manufacturing and desktop manufacturing, whatever we have been doing. So to give a quick background about myself and my colleague Huzefa. So basically, I am an aerospace engineer. In the past 8 years, I am in the same field. I am working across multinationals like Airbus and Boeing. And I have taken as a passion as also desktop manufacturing, and the passion became a startup, and now here we are, basically. So I am in charge of the design and the business development of Speculars. My colleague is basically involved in manufacturing the machines as well as the 3D printing stuff. So today we would like just to take you off track from the two topics that we are hearing, that is AI and IoT. And there is one more thing, if you had observed, called robotics. So we would like to open you a world of desktop robots. It's also called as 3D printing, basically. So before they just get on with the slides, it's already there. Thank you. So,
take this.
Yep, this one. Yeah. So before I go to this slide, if I can show you this shape here in my hand, this is called a gyro cube. Okay. So I am totally sure that there are manufacturing and engineering professionals around here. So if I can just ask one wild question, that if I want to manufacture this part, what can be the best possible route that you can shoot at me? Just a wild guess. Maybe milling, no? Or maybe machining, okay? But now if I say, I want this part just to be done in 4 hours next to me, and I don't want to go to a shop floor. So that's a job for a desktop 3D printer. So if I want to get this shape in 6 hours, which is very intricate, you can see the tool paths are highly complex. I can get it passed on to you later. It cannot be milled. It cannot be molded because it's very difficult to do a pattern for this. Machining is ruled out because it's very expensive for the tooling, and forming is next generation technology for this particular part. So this is basically a job for a desktop printer. So I'm also glad to share our own printer which we have developed, which are going to soon get into the market, and that is the Vinayak Murthy that we have done for the recent festival, basically. So we have been gone through the era of metals, alloys, okay, bygone days. And now in the Industrial Revolution 4.0, we say it's the era of plastics, okay? So anything you see, anything you feel, anything you want to manufacture, they say, let's do it in plastic. It's very simple, okay? So the story of 3D printing basically started with this guy. He is Chuck Hull, who is now the president of Z Corporation. So he coined this word called 3D printing, which was classically, I'm sure electronics people will be familiar with this word, called stereolithography. So the basic misnomer in 3D printing is it is not actually 3D. We are doing 2D printing over and over again on the same layer, and then we build on the structure, and finally we get like this, what do you want, okay? So basically this is an extension of your stereolithography concept, and this person coined the word which is called as 3D printing or additive manufacturing in '82. So going further, to give you a quick insight, as the field is pretty new, we can do 3 types of depositions, basically, okay? So the first level deposition is what everybody do, especially bootstrap startups. It is called a filament deposition method, where you have a filament, you move the head, and you get what shape you want over and over again. The next level thing what we do is sintering. Instead of a filament, you replace it with a metal powder, okay? And you heat the metal powder to such a high temperature that micro welding happens between the layers, and you get what you want. Another thing is a classical one which was using called binder jetting, where the process is similar and the raw material will be gypsum stone, okay? And you have a binder glue which puts one layer of particle and one layer of the glue, and you get what you want, okay? So here the 3 game changing things that we would like to point out is that you don't have to have an initial tool, which is the first bottleneck for manufacturing. Second thing is there is no tool room. You can do it at your desktop, you can do it at your home, wherever you prefer. And the best part is you don't waste material. My printing stops or my manufacturing stops once my geometry stops. So I don't have scrap, so you're going to save a lot of material and wastage. So for the next 20-15 minutes, I would like to walk through classical challenges that we have solved from our company for the industry with 3D printing, some live examples. So the first challenge that I would like to share with you is redefining surgical times or surgery lead times. So it so happened that in the bygone days, this was a terrifying operation theater, so barbaric. There is nothing sterile around you. They cut open the human being there itself and then check what happened, what's not happening. Okay, so the major bottleneck during those days was they could not understand what's happening inside the body without cutting opening the body. What is the biggest bottleneck? So then people started going with a modern operation theater. Here you can see a modern operation theater has very less number of people. You have maybe a head surgeon and a couple of helping crew and a lot of machines. Like our couple of peers who have shared the AI and IoT, maybe you can see everything here. But still, they had to go to one level ahead that, okay, I can see a 3D scan or I can see a 3D image of a particular case study, but I don't know whether my tool fits inside that. I don't know whether the criticality is what I see in the scan or whether the criticality is what in reality. So one of the hospitals in Bangalore, St. Philomena's, came to us and they had this unfortunate patient. She was actually from Uganda. She was not able to stand from her whole birth because she had a dislocated hip, and that is the dislocation you can see there. Okay. So because of that, she approached and they wanted to understand that how quickly they can operate because the patient was anemic. So they cannot afford for blood loss. So you know that in surgeries, the amount of time involved to do the surgery and the amount of time to save the patient is highly inverse. The moment you put the knife and your tools, it should go on. So they approached us and they wanted to understand that can we see what is the structure of the body inside even before I open, because the doctor had skeptical whether he can do it within a given amount of time. So what we did basically was, they gave us the CT scan, we converted the CT scan into a CAD model, okay, and I have the models here for you. For example, this is the right pelvis, which is perfect. This is what we have here, same thing, but a different patient. So this is the right pelvis, what you have, and unfortunately the defective pelvis, okay. So once I gave this model to the doctor, he was tremendously happy because, Girish, like I am able to see something what is happening inside the body even before I cut open. That was phenomenal. Imagine you have a tumor somewhere in your, say, your hypothalamus of your brain, you cannot see, you cannot access, and they want to determine the size of the tumor. So that's the extension I am trying to give you. So this was one of the classic case study we did, and now the patient is fine and we are happy, okay, and we solved the case. So this is the specimen I have. So those are the two pelvis and this is the tailbone we have in between. So a schematic, if I show what's happening in hospitals in Dubai, for example, they have made 3D printers mandatory in their operation theaters. So tomorrow you have a kidney failure or you have a liver failure, no need to search for a donor, no need to search for a patient, 3D print it. And this is not a fiction, this is happening. It takes time to India because we are still working on the scaffolding on the cells, which is very difficult. Okay? So here you see, funnily they are printing crazy things, but should be careful what they print and what they fit. If it's swap, it's dangerous. Okay. So the next case study. Now we will move from a field of medical into a field of machinery. Okay? Machinery is changing things, machinery moves ideas, machinery moves people. But machines move machines. So there are parts inside the machine which move a machine. So sometimes if you don't get that correct part, which is called a spare part, for example, how do you move a machine? That was the challenge. So can anybody tell me this is from which movie quickly? You guys see Hollywood, I suppose. Okay, maybe I'm an old timer. It's Apollo 13 movie. So here you see all the three astronauts are quite perplexed because they had a rapid depressurization inside their cabin. and there was a failure in one of the oxygen cylinders. And there was a cone filter which was fit to that cylinder, could not give you the correct oxygen, and the whole environment was surrounded by carbon dioxide. So now they are looking like that because they had a cone filter which has a circular cross section, but they had a rectangular pipe, and they could not repair it because they couldn't have a circular cross section pipe. Imagine if you had a desktop printer here, they could have printed it and they could have fixed it. So my colleague Huzefa, who has basically worked with the hospital, he'll quickly walk you through with this case study. You can take over.
Thank you, Girish. What we are seeing on the screen here is an open heart surgery. In an open heart surgery, there was one case in my area where a tool is self-retaining retractor. It plays a very important role. What does it do? It keeps the muscle open where the doctor can operate it. So the accident happened that the gear, the pinion, was broken out. So what was the possible situation to print a gear, either machining or injection molding, anything. So it will take a lot of time and very expensive also. So what did a hospital do? They came to me. I have made a CAD design and printed the gear overnight. At the next day, the surgery could happen, and 10 more surgeries could take place, and the original part had come.
Thank you. So basically what Huzefa want to summarize is, the route for this part to do was, as he told, injection molded, or maybe you can say, why don't you go buy the part? But that solution was not possible because you are familiar with the Murphy's law. What it fails, the most you want, it fails. So in this case, the same thing happened, and the supplier could not trace the inventory back. So that's where we took the gear, we 3D scanned it, we restored the tooth, and we printed in a PETG material, and fortunately it served for 10 more surgeries by the time they procured the real metallic part, and now they are back with the machine. So this is what's happening now in space. I show you a real image from ISS, International Space Station, where they have printed a 3D printing tool on space, and now they are not in the Apollo 13 situation, so they are better. So that is one of the edge that we can say in spare parts, what we see in 3D printing. So the 3 takeaways you can have is basically you don't have any inventory, so you save a lot of space or big data, whatever you are calling, for the inventory for that particular scenario. You don't have to hoard your CAD data. It can be minimum to reproduce the part, and no tool room. From Earth to space is the limit. You can do wherever you want. And this is another classic case study that I would like to take to you to the classroom, or I can say the engineering academy, as well as the industry. I am totally sure that there are a couple of engineers who are into CAE analysis. It can be anything from a body part to a car part. And all of you want to see how my part has deformed in the physical space. So again, the maximum thing that you can see is, okay, plus the deformation in softwares, see the deformation mode, and you are happy. But sometimes if you want to analyze how critical is my deformation, so 3D printing is the best route. This is a bracket that we have done. This was an engine bracket, and you can see the structure is little bit clumsy compared to the regular one, because we have done lattices on it. It is little bit of artificial intelligence algorithms that we run with softwares, and it gives me this structure. This is the best strength to weight ratio. Then what we did, engineers are always doubtful, they are not positive like researchers. We are very pessimistic. So they undergo an analysis. Then we got the stress contours. For this particular bracket, what we did, we wanted to show in the physical sense how the stresses are developing in the bracket. So we exported a model and we color printed that. So how beautiful is this? Seeing a deformated wing of an Airbus, for example, on your PC, and the same thing, you see a scale model, you get the real physical sense, oh, this is the level of deformation that Airbus wing is going, and I am flying 50,000 feet. This is something great that they have done. So that gives you that feeling. So this is a classic example which we are talking to industries, especially into the farming industry where they are very much interested in deformations, large deformations, basically nonlinear problems. This is one pinnacle case study that we have done, 3D printing prosthetics. I'm sure when I put this slide, a lot of minds are ringing, oh, there are so many prosthetic models available on the internet, so I think they have printed one from the internet. So let me tell you, this is a different story. So this is an implant that we have basically done, which goes directly into the human body. This was a client from Australia. So the problem in outside India when it comes to 3D printing is not 3D printing. 3D printing in additive manufacturing is only 20%. If you have the money, if you have a place, give the bucks, they give you the machine. But the challenge is, how do you make a design that is printable? That's the challenge. And most of the 3D printing industries, when I talk to India, they say, hey, I have a machine from Stratasys, I have a machine from Ultimaker. Fine, but who is giving you the models? Where are you getting the designs? That's the main thing, right? So they came to me just with a 2D photographs, and we developed that model. I am also sad to say that this is going to be the future of humanity with too much of IoT maybe, because we are not moving ourselves. We want to check the water meter level in an Android phone maybe. So we may land up like this. This is called an anterior lumbar interbody fusion implant. Okay? This was again done for Sakara Hospital in Bangalore. And the basic mentality of doing this was they wanted to get this metal 3D printed in titanium. If you ask me why titanium, because titanium is the only metal which is compatible with the human body on which bone can grow. So we do cranioplasts, for example, for the skull, we do mandibular implants for the jaw, and this is one which goes in the spine. So the part of our company in this was basically design that, and we had to run a lattice algorithm, because printing such a part in 3D is, one is costly, other it is not required. You're going to save a lot of material. So for that case, we created a lattice in metal. And this is actually what Mother Nature is doing with us, I will tell you. And one more classic implant case is this. We were very happy when we did this, because we work with Mobility India, which a couple of people will be aware. Mobility India is the pinnacle rehabilitation center in India, and this patient is a leprosy patient basically. So there they come to restore their limbs. Mobility was working all the day with legs. They did not give hand a thought, because trust me, making a prosthetic hand is very difficult than legs, because prosthetic hand demands more functionality than legs. So we designed this hand completely. Again, this is our own design, not available on the internet, because there are a couple of hands which are floating in Google. So this is a complete design of ourselves. And this guy, we have tested with him, and he was able to lift close to 20 kilograms. And he is a Bangladeshi, and we gifted him the hand, and we were very happy. So after this, we made around 5 to 10 prototypes. Now we are improving this with carbon fiber, basically, because now this is PETG plastic. So additive manufacturing is nature's way. I am totally sure that all of us have seen additive manufacturing in your life. It's a 50 million year process. If you ask me how do the plants grow, how the trees grow, how you grow, how I grow, everything is additive manufacturing. That is the nature's way, where it adds material layer and layer and we grow up. As simple as that. And this is what we have learned, how to embed nature's philosophy into softwares, and I can make additive structures or lattice structures. If you see this plant, such a beautiful thing which a human being can never ever do with any technology he has until now. The branches are so slender at the top and the stem is so thick. So it is adding material where it wants, and it is not adding material where it does not want. Okay? So going further, we are willing to connect the dots. That is basically, if I can say, robotics, which is already our 3D printer basically, and Internet of Things. If you can ask me how we are trying to connect that, Internet of Things has two parts. You have your software and you have your hardware, I am totally sure. So if you want to make devices which are functionable, you need a hardware to encase your software, right? So we reduce lot of your downtime, we reduce lot of e-waste by producing the products with 3D printing, so that you can reduce your prototyping time. So we work with multiple verticals, okay? So we have worked across all these verticals for design as well as 3D printing, and we would be willing to network with people who require us and we require them, okay? So thank you for your time, for sharing your patience with us. Thank you.
Thank you. Any
Yeah,
questions?
please.